resistors are connected in series combination or in a parallel combination, right? So here now we are going to solve simply numericals, right? So yesterday I gave you two formulas. What they are? Can anybody? I got two formulas. Equivalent resistance, right? Equivalent resistance. So what is the equivalent resistance formula? If two or more than two resistors are connected in a series combination, or effective resistance also we can call it as, right? Here equivalent resistance or effective resistance. So what will be the equivalent resistance if they are connected in a series combination? Can anybody answer me? Give me the formula. In series combination. For example, here I am giving you resistance values as R1, R2, R3 respectively. If these are connected in series combination, what will be the equivalent resistance? 1 by or directly or equivalent? Respond. Don't know anyone? So here equivalent resistance in series combination is sum of the individual resistors. Yesterday we derived the relation or equation to find out the equivalent resistance. Suppose if these resistors are only connected in a parallel combination, right? In parallel combination. So what will be the equivalent resistance? That equivalent resistance is reciprocal of equivalent resistance is equal to reciprocal of sum of the individual resistances. So these are the formulas we got. Right? So now here we are solving the numericals based on the relations. So the first problem is given like this in your textbook, page number 195. Right? So here, can anybody draw the diagram for this combinations? First of all, it is asked to find out in series combination, and the next one is asked to find out in a parallel combination. Suppose if you draw the diagram, circuit diagram for these resistors. So the first one is series. So here I am taking a battery. So with the battery or with resistors, they are in series combination. So resistor symbol is this one. First resistor, second resistor, and third resistor. They are all connected in a series combination. Right? So this is the circuit diagram for the first one. So 10 ohms, 20 ohms, and 30 ohms. Right? With the battery, and here it is key. So this is circuit diagram. Then how do you draw the parallel diagram? Parallel combination of circuits that are resistors. So parallel, draw the parallel lines. How many resistors are given? That many lines. So now take it as a branch, then complete it. So 3. How they are connected in parallel combination? To make it parallel with the battery, just you can connect all these parallel branches. Then select any point, then connect it to the battery. So this is the circuit diagram for the resistors which are connected in a series combination and in parallel combination. So first one is series combination, next one is parallel combination. So what we know, from positive terminal to the negative terminal, the current will flow. So here the current pass through these three branches like this. Right here the current direction is same through any resistor from positive terminal to the negative terminal. Have you got clear idea about this circuit diagrams? What I did? Photo quick reaction. Was it clear? Yes. Yes. Right. So I draw on circuit diagrams. But actually our question is not to draw the circuit diagram, to find out the resultant resistance. Right. That resultant resistance is what? Equivalent resistance in series combination and in a parallel combination. So I know the formula in series combination, right? In a series combination, that formula is here R equivalent is equal to sum of the individual resistances. So R equivalent in series combination is sum. So look at this code I am using, series sum. So R1 plus R2 plus R3. Then R1 value is taken as 10 ohms, R2 value take it as 20 ohms, and R3 value taking as 30 ohms. Then 10 plus 20 plus 30, it is 60 ohms. So equivalent resistance of the whole circuit by these three resistors will be given as 60 ohms. So R equivalent or effective resistance in the combination, right? Series combination is 60 ohms. Then now find out in parallel combination, what will be the equivalent resistance, right? So now look at that. Here 1 by R equivalent in parallel combination is RP, first letter, last letter, reciprocal. So 1 by R1 plus 1 by R2 plus 1 by R3. Then substitute the values. 1 by R1 is 10 ohms, R2 is 20 ohms, R3 it is 30 ohms. Then find out LCM. So what is the LCM? It is 60, right? It is 60. So here follow easy logic, that denominator imagine as a table, right? And it is your answer to get by the multiplication, right? So 10 table 60, how many times? 6 times, 6 by 6. Any change in the equation? If you cancel, then it remains as 1 by 10 only. Then use it as 20 table. How many times? It will be 60, 3 times. So 20, 3 by 3, right? 30, 2 times. So this is easy trick for your LCM. So all the denominators, 10 times 6, 60, 23 times 60, 32 times 60. So I got the numerator 6 into 1. 6 plus 1 into 3, 3 plus 1 into 2, 2. That is, I am getting 1 by R equivalent in parallel combination is equal to 6 plus 3, 9 plus 2, 11, 11 by 60. So writing reciprocals, then what I will get here? I will get, that is R equivalent in parallel combination is equal to 60 by 11. If you cancel it, 5 times 55, then 5 left, again it is 4 times 44, 6 left, 5 times 4, 5 left, 4 times. So it repeats 5.4, 5.4, 5.4 like that. So I got equivalent resistance will be 5 point, approximately it is 5.5 ohms, right? 5.5 ohms. So here R equivalent in parallel combination is given as 5.5 ohms. R equivalent in series combination given as 60 ohms. Here my question to you, in which combination that the equivalent resistance will be greater? Answer me. Unmute and answer. In which combination of that same resistors gives you lowest resistance or highest resistance? One answer. Kaushik, join with your audio. Vikrant, answer me. In which of the combination of these three resistors, 10 ohms, 20 ohms and 30 ohms, you will get lowest resistance? Is it in the series combination or in the parallel combination? Am I audible? Give me a quick reaction. Am I audible or not? Yes, audible. Why you are not responding? Okay, Tejaswini, answer me. In which of the combination of these three resistors, 10, 20 and 30, you will get lowest possible resistance? Here the first one is series combination, next one is parallel combination. So it is given by parallel combination. So if you compare equivalent resistance with any of resistance in a series combination. So in series combination, I got 60 ohms. That is greater than the greatest resistance among the three. Yes or no? Yes or no? Have you got idea what I am trying to say? In the series combination, that equivalent or effective resistance in the whole circuit will be greater than the greatest resistance. What about in parallel combination? That equivalent resistance lower than the lowest resistance. So here R equivalent in parallel combination, I got 5.5 ohms. It is lower than the lowest resistance. Have you got it? Use your quick reaction. What I said, if you understood. Yes. So to get lowest possible resistance, how to connect them in parallel combination? If you connect them in series combination, the resistance in the whole circuit will be greater than the greatest resistance. That is. The next, look at the second example. Look at the second example. So what actually asked here? What actually asked here? Simply, it is asked to solve. It is asked to solve that simply equivalent resistance again, right? But equivalent resistance already given you. Here, equivalent resistance already given you in the question. Look at this. If the resultant resistance in the circuit is 20 ohms, in which combination they are connected, that you need to observe. Here they are connected in series combination. If you connect them in series combination, that equivalent or effective resistance will be taken as sum. So R1 plus R2 plus R3 plus dash dash. Here you have given by only three resistors, so no need to write the plus dash dash. This is only enough. Then here, how to solve this one? Simply substitute the values. Here R equivalent in series combination, that resultant resistance is only equivalent resistance given as 20 ohms. Then R1 value is 1 ohm, R2 value is 4 ohms, R3 value is 8 ohms, right? Then, sorry, first one is not given. First one is not given. It is given as R1 ohms. It is given as R1 ohms. So R1 equal to, don't know, that R1 only, right? So here it is asked to find the value of R1. The value of R1. So let me substitute those values in the relation. R equivalent in series combination will be given as sum R1 plus R2 plus R3. So that resultant resistance R equivalent is given. So that I am substituting here as 20 ohms. That equal to R1 already given as R1 only. R2 given as 4 plus 4, then R3 given 8. So what I will get? R1 is equal to 20 ohms minus 4 plus 8 is 12. So transposing towards left side, so will be written as minus 12. The difference is here 8 ohms. The difference is here 8 ohms. So here I got answer here 8 ohms. I got the answer 8 ohms. So that R1 value is equal to 8 ohms. R1 value is equal to 8 ohms is the answer. Are you clear about this problem? Are you clear about this problem? Right. So small change in the question, same question only, but I'll make it small change in this. Right. While I am preparing the question paper, just I forgot to mention this combination. Just connected in a combination. Just I wrote, I connected in a combination, but I don't know that combination. Right? I am not given you. Can you identify what the combination I followed in this? What the logic is? What the logic is? What the logic is here? To find out. Right? I forgot to mention the combination in the question. Can anybody? I forgot to mention the combination. Just and given as you connected in a combination. If the resultant resistance in the circuit is 20 ohms, find the value of R. Small variation in the question. Right? Will you take this question as wrong? Will you take this question as wrong, or are you able to answer this? Speak out. If you are silent, no use. Just I will go on according to your textbook only. No need to discuss new problems. If you want, just speak out. It may be wrong or right. Answer me. Rohit. How do you answer for this question? Rohit. How to solve this one? How to solve this one? Is there any logic to identify? Medustry? Is there any logic to identify here? What the type of combination is this? Don't go for this. Just leave it.
Resistance is greater than the
Very good. So equivalent resistance is greater than the individual resistance. It may be R1 or R2 or R3. Among all the resistance available in this combination, that is smaller than the equivalent resistance, or that equivalent or resultant resistance is greater than the greatest resistance. So this logic will help you to identify that as this combination, right? So simply the solution will be written same as you see on the screen. No change in the solution. Got it? Are you clear now about this problem? How to solve? Go to quick reaction. If it is clear, yes. So think, right? Whether the given question is wrong or right, or if it is wrong, whatever it may be. If wrong, they will add you that marks. But what about your knowledge? Just verify, right? So then now, question number 3. Question number 3. Then how to solve this? Can anybody just give me the logical method of solving this one? Here, two resistors are given, R1 ohms and 12 ohms are connected in parallel combination. If the resultant resistance in the circuit is 3 ohms, find the value of R1. What is the equivalent resistance in this combination? That is reciprocal. So 1 by R equivalent in parallel combination is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. But here I have only two resistors. If the two resistors are only given, just leave about these things. No need of this. Then what to do? Just you are able to take LCM of this formula. That is what R1 into R2 in the denominator. Then what about numerator? Cross product. Right? So R1 into 1, that is R1 only. R2 into 1, R2 only. So 1 by R equivalent in parallel combination, I got R1 plus R2 by R1 R2. If I write reciprocal, what I will get? R equivalent in parallel combination will be written as R1 into R2 by R1 plus R2. So I have direct formula to find out the R equivalent in parallel combination. Then here simply substitute the values are given in the formula. What they are actually given you? R equivalent is given. That is 3 ohms. Then R1 equal to R1 only. R2 equal to, it is given as 12 ohms. Then substitute R equivalent given as 3 ohms, that is equals to R1 as R1 only into R2 given as 12. So 12 into R1 or R1 into 12 will be written as 12 R1 by R1 plus R2 is 12. Then take the cross product. If nothing there means by 1, 3 by 1, right? So if you write or not write, no problem. Then 3 into R1 plus 12 is equal to 12 R1, right? Plus 12 is equal to 12 R1. Then here multiplication, expand. 3 into R1, 3 R1. Right side 12 R1 is there. 12 R1 minus 3 R1. So it is transposed to right side. Then what is left on LHS side? 3 into 12. That is 36. Then difference is it is simply 12 minus 3 is 9. R1 is equal to 36. Then R1 is equals to 36. On transposing 9 towards right will be written as denominator. Left side multiplier. So 9 once and 9 4 times. Then R1 equal to 4 ohms. R1 equal to 4 ohms. Right? So this is the solution for the example 3. Are you clear about this one solution? Is it clear? Use your quick reaction. Yes. So clear. Right? Then last example of this topic, numericals. Right? So that topic is here. This question, example 4. Right? Observe the given circuit. So what the circuit is given here, I am going to draw on the screen now. So the circuit diagram is given like this as you see on the screen. This is your circuit diagram given in the figure number 22. So 4 ohms, 12 ohms, and 7 ohms. Right? 4 ohms, 12 ohms, and 7 ohms. And the battery voltage is given as something V. Right? Here you have the current also something I. Right? So whatever it may be, I value, V value, irrespective to that I and V, you are able to find out the equivalent resistance. So what is the equivalent resistance in the whole circuit? Here, only one type of combination is given or multiple combinations are there. That means parallel in the series or series and parallel, whatever it may be. Both are available, only one type of combination is there, either series or parallel. Surajita. Tell me the combinations here between the resistors. No? Proceed.
Sir,
Answer me. Combination in this. How they are connected. Are they in the same combination?
no, sir.
Then
Sir,
what?
4 and 12 are, sir, 4 and 12 are in parallel.
4 and 12 are in
Parallel.
parallel combination.
4 and 12 are series to 7.
So if they are in parallel combination, you will get equivalent resistance of those two resistors, that is REP. That equivalent resistance is in series combination, right? Series combination with 7 ohms resistor. Is this correct? What I am written?
Yes, sir.
Yes. So I got what the combination is there between the resistors. So I can do the solution now. So 4 and 12 are in a series combination. Then what I can do? So I will find out equivalent resistance of those two resistors. Right? So what is the formula? 1 by REP, or directly two resistors are given means you can use the formula R equivalent in parallel combination equal to R1 into R2 by R1 plus R2. Then substitute that values in the given relation, that is here simply R1 is given as anything 4 and R2 is 12 by 4 plus 12. So the denominator is 16 and numerator is 4 into 12 as it is I am keeping here for easy cancellation. 4 1 4 times, 4 1 4 3 times. So what is left here? 3. So equivalent resistance in the parallel combination I got REP is equal to 3 ohms. So that 3 ohms now is in series combination with 7 ohms. So here simply R equivalent in a overall circuit is equal to REQ in parallel combination plus 7 ohms. That is equals to 3 ohms plus 7 ohms will be give you 10 ohms. Is it clear? How to solve? Do you got clear idea about this one? How I got? So this is the topic about numericals on equivalent resistance, right, of resistance in series combination or in parallel combination or in a multiple combination, right? Then we will discuss the same topic in the next meeting. Join immediately.